We are going to learn about scientific notation. Scientific notation is useful not only in math classes, but also in science classes. Now, what is scientific notation? Scientific notation is a way for us to express numbers that are really big or really small. For scientific notation, we will look at the first number that is between 1 through 9 inclusively, meaning that numbers 1 and 9 are included. Then we will have a decimal after that number. Then we will count how much to raise to the power of 10. Scientific notation will be 10 to the some power. So if that was confusing for you, let's do an example. Let's say we have the number 46,000. How do we write 46,000 in scientific notation? The first step is to look at the first number that is between 1 and 9 in this number, which is 4. Then you put the decimal after the 4. Then you put the number after the 4, which is 6. Now, let's look at 46,000. When we keep a decimal after the 4 and count how many we have left to the end, we notice that we have 1, 2, 3, and 4. Therefore, we have the answer 4.6 times 10 to the 4th power. Let's do another example. Let's say we have the number 0.0000729. How do we write this in scientific notation? The first step is to look at the first number that is between 1 and 9 in this number, which is 7. Then you put a decimal after the 7. Then you put the numbers after the 7, which are 2 and 9. So far, you have 7.29. Now, let's look at 0.0000729. When we keep a decimal after the 7 and count how many we have to the beginning, we notice we have 1, 2, 3, 4, and 5. Notice the difference between the last problem and this problem. In the last problem with 46,000 technically has a decimal here. We were trying to count the decimal places from after the 4 to the last decimal after the 0. In this problem with 0.0000729, we are trying to count the decimal places from after the 7 to the decimal place in the front. And since 0.0000729 is less than 1, we will be raising 10 to a negative power. Therefore, 0.0000729 in scientific notation is 7.29 times 10 to the negative 5th power. Let's try an example where we start off with a number in scientific notation. Let's say we have the number 4.5 times 10 to the negative 4th power. How do we convert this to a regular number? When you have a negative exponent, you move the decimal to the left. When you have a positive exponent, you move the decimal to the right. In this case, the exponent is negative 4, which is a negative number. Therefore, we move our decimal to the left 4 times. 1, 2, 3, 4. Therefore, we get the number to be 0.00045. Let's try another problem. Let's say we have the number negative 6.7 times 10 to the 5th power. This number is in scientific notation. How do we convert this to a regular number? Keep in mind, when you have a negative exponent, you move the decimal to the left. When you have a positive exponent, you move the decimal to the right. In this case, the exponent is 5, which is a positive number. Therefore, we move our decimal to the right 5 times. 1, 2, 3, 4, 5. Therefore, we get the number to be negative 670,000. Let's do more practice problems. Let's say we have the number 0.153. How do we write this in scientific notation? The first step is to look at the number that is between 1 and 9 inclusively. That number, in this case, is 1. Then you put a decimal after the 1. Then you put the numbers after the 1, which are 5 and 3. So far, you have 1.53. Now, let's see how many decimal places we moved. 1. And that's it. Since 0.153 is less than 1, we know that the number in scientific notation is going to be raised to a negative exponent. Therefore, 0.153 in scientific notation is 1.53 times 10 to the negative first power. You can also check your work. 10 to the negative first tells you to move the decimal once to the left. When you move the decimal once to the left, you will get 0.153, which was the number we started off with. Let's do another example. Let's say we have the number 2,320,000. How do we write this in scientific notation? The first step is to look at the first number that is between 1 and 9. That number, in this case, is 2. Then you put a decimal after the 2. Then you put the numbers after the 2, which are 3 and 2. So far, you have 2.32. Now, let's count how many decimal places we moved. Keep in mind that, for this math class purposes, 2,320,000 equals 2,320,000 with a decimal at the end. So let's count the decimal places we moved. 1, 2, 3, 4, 5, and 6. Since 2,320,000 is greater than 1, we know that the number in scientific notation is going to be raised to a positive exponent. Therefore, 2,320,000 in scientific notation is 2.32 times 10 to the 6th power. You can check your work as well to see if your answer is correct. 10 to the 6th tells you to move the decimal 6 times to the right. When you move the decimal 6 times to the right, you will get 2,320,000, which was the number we started off with.